This example comes out of section 6.3, proving identities. We have an identity that at first glance looks like a nightmare. It's pretty big, lots of stuff going on, squares, cubes, double angle identities. Let's set it up and see where we go. It actually turns out not to be that bad if you can factor. First thing you might want to look at right away is you have a double angle there, which means we do need to change that to 2 sine x cos x minus cos x on this left side over 4 sine squared x minus 1. On the right side, I do see some factoring I can do right away, and that is I can take out a cos x in the numerator, leaves me with sine squared x plus cos squared x, and all that divided by 2 sine x plus 1. Hopefully sine squared plus cos squared jumps out at you as something that you can simplify very much, which is it just equals 1. So on this right side I now have cos x over 2 sine x plus 1. That sine squared plus cos squared term just goes away because when you multiply by 1 it doesn't do anything. Now on the left side I do have some factoring I can do on both the top and the bottom. On the top I can say, well, I've got cos x times 2 sine x minus 1. On the bottom I have a difference of squares. If you recognize that as the difference of squares, good for you. We should be able to factor that as 2 sine x minus 1 times 2 sine x plus 1. Now that things are factored, if we have common factors we can cancel, and we do have one significant common factor, which leaves me with cosine x on top, 2 sine x plus 1 on the bottom, left side equals right side, and our identity is proven.